are done. I've already a couple of times today. Remember, it's the details you have to pay attention to so you don't get yourself confused, because it's kind of easy to think backwards. And so it'll be, everybody will be fine. I just don't. Not all new. It's too young. All right, let's look at critical points. Critical points on a graph, right? This is some, we don't know what the equation points where the graph changes its direction or, okay, so if the graph changes direction, there's a critical point there. Here, we're direction. Here we don't change the direction, we just change the shape. And then here we change means by direction. Critical point. We have a minimum or maximum value points. So the value, remember what I said, if you're going to find the value, the function value, value. It's a y value. Okay? So then we have a point of inflection. Heard the word in different context, like not math related. Like if you have a voice inflection, right, it means your voice changes or shifts a little bit. We also with where the graph changes its shape, not its direction. That's important. Here, it changes direction, will also change, right? Here. So we have relative and absolute extreme. At least a little bit, whatever level you were in. But it has the highest y value. It's all these critical points is something that you look at a lot in calculus. And for us to actually calculate them algebraically, it takes skills that we don't have. So right now we're just being able to identify them, know how to name them, things like that. Also look a lot at just restricted domains. Entire domain, this maximum over a restricted domain. Just looking at what happens right, how you determine things. So if you have a point with the greatest value compared to the point around it, this is value over the entire domain. have an absolute minimum or a relative least value compared to the entire domain is I understand how to identify them. And we're algebraically, you know, do right now. Just don't actually need the. So here it says give the coordinates, classify the critical points for the graph of the function. So when I look at number 1, and ordered here 2, 3, 4, 1, 2, 3, 4, -5. Do you all agree with that? You know, like follow the graph. We have this one, and then we have this one, and then we have this one. Now here's where in a nasty little way, because these don't all hit the little grid marks. So if something is not a whole number, we're just going to make it a 0.5. Okay, just to be, it's not that we don't have to estimate that closely. It's really fine. Absolute maximum. Good. So this is an absolute maximum, and then 1.5. Right, and then 3. Was that one kind of on there? No, that one's -2. What did I do? Kind of in between. I'm not going to be, and I know the graph is tiny. Yeah, it's all good. And I know the graph is tiny. I'm not going to be crazy about this if you're off a little bit. If you can clearly at the right point, I'm okay. 1.5. So then would be at 0.5 maybe. And then, no, yeah, -4.5. It's not. Now the y values go all the way down to -infinity. So can we use -infinity as an absolute minimum? Let me ask you this. The extrema, where the function, well, first of all, does it change direction down there? The answer is no. And it's also a minimum or maximum value. Is infinity an actual value we get to use? No. So infinity is not ever going to be a maximum or minimum. Does that make sense to you? So, yes. All right. -3, point. Y'all agree with that one? Okay, good. And that point would be at like -0.5 what? 4.5? Yeah, I know the grids are really super small. So how many critical points do we have? 3. I have this one, and this one. Okay, so you have a and what would the very good, and then 6. Then what's right here? What's that wiggle? Because we don't change direction, we just change that one called. It's okay, you can look on your notes, that's why we have them. Inflection. So the wiggle, where it's just a point of inflection, but it's not a max or a min. Okay. That would be right. This last what's it? Just everybody. What's relative? Good. Relative min, and I would say 1.50. Would y'all agree with that? Okay. Identify, right? Just make sure you know the terminology and how to use each one of them. Point of inflection, although I know you've seen them in graphs, I don't know if those words have been used with you before. What graph have you seen a point, what parent function has a point of inflection in it? The cube. Cube function. Because all right, so let's look at it increasing and decreasing. Now, but at the same time, writing things down, people get things backwards and confused sometimes. And so let's make to write. That's important. We are always moving. The I move from left. Negative infinity to 1, or -1 is where it's increasing. I never include negative infinity. Right? Here, constant from negative what? I don't include it here, or if I include it, make a whole finger chat. If you're and so I'm not going to include either one. So in decreasing, they are tells you to do. From 4, you will have to go back and remind yourself. I can say it to myself so the wrong thing doesn't come out. When you're decreasing, although again, it's pretty kind of what's going on is increases. So okay, that I've moved from left to right, right? Moving along here. The y values are so the y values decrease. Now here, make sure you're doing the right thing. This ordered pair here, so that y value is 4. Decreasing from 0 to 3. I'm sorry, not 0. Negative infinity to 3. Increase from infinity. What? 5. Yeah, to negative 5. Now, what is actually 5? What an asymptote? I have an asymptote. At negative 5, I have a value. And what is happening? From really, really small to really, really big, but that's from negative 5 to infinity. Because our two intervals, I put my have a union when you have one. You have one. Okay, that's a good question. All right, so what are my increasing intervals? Let it soak into your brain. Let me know if I need to repeat all that. Like this one I had to repeat like 3 times last period because I think some people were just having trouble processing the fact that it was decreasing the whole time. Are we good on that? We see how even though it jumps, it's still decreasing? And that's with your pencil and think about what's happening. You're not getting yourself. Yeah. All we're looking at is what is happening to the y values. X value is increasing, but all these y values is getting smaller and smaller and smaller. And I know I have to stop there. Back up on the other side of it, even though this is a giant number and it jumped, it's still, the y values are still decreasing the entire time. Okay. Number 7. It's happening to my y values. They're increasing the entire time. Nothing changes. There are yes, yeah, because it's specifically asking you for intervals, so it has to be interval notation. You don't get to make a choice. Does that make sense? All right, so I want you to do number 8. Just do number 8 and stop, and we'll talk about it. Make sure we can make x's because the wrong thing. Good. Any questions about that? That was a good question about being negative. Y'all do number 9. Then 1 to infinity. And what else do I need there? A u. Good. Agree with that? Yes? Okay, good deal. So, any decreasing intervals? Linda. Okay. And then u. Now, why don't you look at that? See if something's missing there. I know what you mean. You might even have it right on your paper, but what should it be? Negative infinity, right? Negative infinity. I didn't know if you just left it off or yes, y is coming from infinity, the y values. But remember, it's the x intervals. So we're starting at negative infinity and coming this way. Does that make sense to you? Okay, good. So yeah, that should be a negative infinity. For all of y'all that erased the negative since I didn't write it. Don't get ahead of me. Okay, good. All right, so y'all work it. I'm going to pass out the you're working on number 10. Mm-hmm. I don't know. It's not really an argument. See. Uh-huh. Whatever it's doing there, then there's no reason to stop. Does that make sense? Okay, so y'all have some good questions. Didn't fully answer, I know. Everybody make it before I just give it a. See if, are you pointing? Nope. So always start with I'm starting right. It's going infinity to increasing. The question that came up a lot, only kind of half answered. I really didn't get a full answer. We don't separate them. So you told me, right? So if we think of y values of something we know, our y values for this cubic, the y values are increasing. They're increasing quickly. They slow down, but then they speed back up. But the whole time they are increasing. Make sense? So all this is a point of infinity, just like this. So that whole thing being increasing. Okay, does that make sense to you? Okay, very good. You have anything? Yes, sir.
So when it's at zero, like technically not, like you know what I mean?
Okay, it's not moving when you're thinking about that. I mean, like it depends on how you're thinking about what's happening. You don't have to break it up. It's not that it's not changed. Like here, decreasing, but it's still because the point right before that zero is slowly. Okay, does that make sense? Okay, good. Anything else? So you have your assignment. It should go pretty quickly. You have a little over 10 minutes. You can get maybe all of it done. It is. You done.